So Newton's first law is that an object at rest will stay at rest unless acted upon by an unbalanced force. So here, Juan is an object at rest, and my foot is an unbalanced force.
Alright, Newton's second law is that the greater the mass of an object, the more force that's required to move it. In other words, force equals mass times acceleration. And this ball has very high or great mass, and I have very little force. So when I kick it, ow, it doesn't move. This ball has a very small mass, so when I kick it with the same amount of force, it will move.
Newton's third law is that for every action there is an equal and opposite reaction. So for the action of me pushing against this wall, there's the reaction of me moving backwards over here.
So we were given a problem in which Juan pushes a 10 kilogram cart with 100 newtons at an angle of 45 degrees. So here we drew our free body diagram, and we have the force here, which is 100 newtons, at an angle of 45 degrees, and this is your 10 kilogram cart. And so to solve for acceleration, we want to find the force in the x direction. And so to do that, we did cosine of 45 times 100, so that we get that there's 70.71 newtons of force in the x direction. And using the equation force equals mass times acceleration, we have force and the mass of the cart. We solved that the acceleration of the cart would be 7.071 meters per second squared. So I'm going to use my fancy schmancy speedometer to figure out how fast this cart is accelerating. Alright, so Juan, I want you to push with 100 newtons of force.
Yeah, that was about right.
Oh, it's 7.071! So friction is a force that always resists motion. So it will always be in the opposite direction as motion. And the coefficient of static friction is always going to be higher than the coefficient of kinetic friction, because it's always harder to get something to start moving than it is to keep. So the friction between this hardwood floor and this hockey puck is fairly low. So if I were to throw this puck, the puck would keep going. So the friction between the same hockey puck and this carpet is going to be a lot higher than it was on the hardwood floor. So if I were to throw this puck on the carpet, it won't travel nearly as far. So here we're given a situation where books weighing 3 kilograms are being pushed by a force of 20 newtons, and the coefficient of friction is 0.3333. And so the first step is to find the force of friction, and to do so you multiply the force of friction by the normal force, and you get 9.8 newtons. So then to solve for acceleration, we want to get the sum of our forces. So we do 20 newtons, which is our applied force, minus the force of friction, which is 9.8 newtons, and we get 10.2 newtons. Then we plug that into the equation force equals mass times acceleration. So we have the force, the mass of the books, and the acceleration, and we can solve that the books would accelerate at 3.4 meters per second squared.